Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to take a look at what is this number data type in Python and complete details about them by considering the different category of numbers that are available in Python. Followingly, we are going to get into the most interesting part of our curriculum, which is nothing but live coding lecture. So we are going to start our live coding lecture with numbers and variables in Python. And the IDE which we are going to use all through our lectures will be Jupyter Notebook. Okay, let us get into the details of numbers in Python. We are going to majorly focus on two categories of numbers, one being integer, the other being floats. So what are integers? Integers are any number without decimal point. So given a number, and if that number does not have a decimal point, then it falls under the category of integer data type in Python. Let us now take a look at what are the range of values that could be stored as part of integer data type. Theoretically, we can store infinite values under the category of integer data type. How is it possible? This is true in case of Python 3. So integers in Python can be of signed or unsigned in nature, and there is no mandatory upper and lower bound values for integers in Python. So how does the maximum size of value in Python, especially for integer, depends on? The maximum size of it purely depends on the memory of the underlying machine on which the Python is running. Thus, any number which does not possess any fractional or a decimal part in it falls under the category of integer data type. It could be a positive, that is unsigned, or a negative, which is termed as signed number. Let us now get into the next category of numbers in Python, which are nothing but floating point numbers. Any number which have a decimal point falls under the category of float in Python. So a floating point number is a type of number which will have a decimal point. And how does they get represented in the computer hardware? They get represented in the base 2 format for efficient computation. What do we mean when a number is represented with base 2? It simply means that the number is getting represented in the form of zeros and ones. When we say a number is represented with base 10, it means it is represented between the values 0s and 9. When we say it is represented with base 16, we mean that it is represented between the values 0 and 15. Coming back to our floating point numbers, they are directly represented in the form of base 2, that is zeros and ones, for efficient computation on the hardware level. And also there is one more point which is to be noted here. Floating point number has a decimal part and the integer part, or the non-decimal part. So this floating point number can accurately store up to 15 decimal places. There are some set of limitations that exist during arithmetic operations using floating point numbers. We are going to circumvent or overcome them using following methodologies. Using something called as round function, using a decimal module, and a fraction module. Now what the heck a module is? Do not get panic for a moment. We are going to take a look at the limitations in detail during our live coding lecture. Followingly, I'm also going to take you through what do we mean by a module, how does this look like, how can we use them, along with the details of how do we overcome the surprises that we are going to see during the arithmetic operation using floating point numbers. With this, let us now directly jump into the live coding lecture to work with numbers, variables, and different concepts that we discussed till now. I'll be using Windows operating system all through our coding lectures to perform different operations in Python. Okay, as we discussed in one of our previous lectures, we had a thorough understanding of the behavior of Jupyter Notebook. If you are using Mac or Linux, feel free to go to the terminal and go to a directory in which you want to store all your source code in the form of Jupyter Notebook. Okay, let us now launch our Jupyter Notebook from the command prompt for Windows user and from terminal for the Mac or Linux users. What's the command to launch Jupyter Notebook? Here we go. Jupyter followed by notebook and press and enter. Wait for a couple of seconds. This will try to run the Jupyter server on your laptop and opens up the Jupyter Notebook in your default browser from where we are going to actually code Python programs. Ensure to not close the terminal from which we'll launch the Jupyter Notebook command, which makes sure that the Jupyter server is active and keeps our IDE up and running. So let us proceed ahead and create a new notebook of Python 3 runtime. This opens a new notebook in a new tab of browser. Fair enough. Go ahead and click on the title section. Try to title it or name it as numbers and hyphen integer. Okay. Now here we see our instruction bar to feed our instructions to the program. Before we get into details of numbers, let me have a talk about something called as a print function. Functions are generally of two major categories. One is user-defined function. The other category is termed as built-in function. Print function falls under the category of built-in function. Don't worry much about what functions are. We are going to get into its details in our future lecture. Print function straight away takes the input provided by the end user and outputs onto our console. So we will keep using the print function to know the different results, different data structures and different data types all through our coding lecture. Okay, with these details about print function, let us start our coding lecture. Let us try to name our Python notebook title or header as numbers followed by integer. How do we run the cell? As we discussed in our notebook introduction lecture, we can press Shift Enter and get into the next cell by executing the existing cell. Okay, let us now try to type a number with a value of 120. Due to the IPython nature of the notebook or interactive nature of the notebook, we are going to immediately see the output of our input program or our input instruction set. Okay, now to verify what is the type of this number, we are going to use a function named as type, which is also another built-in function, and pass the value called 120 to it. If we see now, the type of this number is nothing but an integer or int. I mentioned in one of the previous lectures that every element in Python is an object. Every data type in a Python is an object. So how do we verify whether it's an object or not? Before that, let me give you a hint. Object is something that comes out of a class, or that is something which is based on a specific class. What do we mean by a class? What do we mean by deriving an object out of a class or instantiating an object out of class is something which we are going to deal during the object-oriented programming lecture. But for now, let us take a look at the verification point of, if I want to say that this is an object, it should be something which is derived or coming out of a class. Now, let us get into the next instruction and place this entire type function inside print function to know more details about the object. Okay, I'm going to pass this type of 120 inside print function and execute the cell. Now we are going to see that this is of class integer, or the object int is derived or created out of the class int. So that means int is an object. Okay, with this basic understanding of the type of the specific data, let us now proceed ahead and try to do some kind of arithmetic or mathematical operations using these numbers. Let us now try to add some integers, let's say 10 plus 20, and execute the cell. We are going to see the output as 30. Let us now try to add some negative integers and positive integers, which is going to again yield us some result. And let us now try to add two negative integers. Yes, we're going to see minus 10, minus 20 as minus 30. So in all these cases, the operator plus did addition operation between either two unsigned integers or two signed integers or a signed and an unsigned integer. Okay, that is addition and subtraction operations. Let's say we want to multiply two numbers or two integers. How do we do it? Let's take one of the operand as 10 and the other operand as 30. We are going to use an operator called into or star that's going to compute multiplication between the two. When I say 10 into 30, it's going to output me 300. Again, the two operands can be either signed integers or both can be unsigned integer, or one signed and the other one as unsigned. Let's take a quick look at it. 10 into minus 20 or minus 12 into minus 2. So the multiplication operator takes both of the category of integers as its operands. Let us now have a look at how do we raise the power of a number. Here we go. Let me take an integer as 19 and I'll use this time two multiplier operator or two stars and put another integer value here. What does that mean? 19 to the power of 2. For example, let me take another simple integer called as 10 and raise it to the power of 2. We're going to see the result as 100. If I say I'm going to take an integer value again as 10 and raise it to the power of 3, it will become 10 into 10 into 10, which is 1000. So 10 to the power of 3, 10 to the power of 2 and 19 to the power of 2. So if you want to raise an integer value to its power, we are going to use two multiplier operators or double multiplier operators followed by the number, which is nothing but the power to which the left operand must be raised. Okay, after going through different arithmetic operators, let us now take a look at if we have an input value which needs to be converted explicitly to an integer, how do we do it? We have a function called int or int, which is going to convert, let's say, string or any different data types to integer value. For example, if I have 10 within single quotes, I could easily convert it into integer data type using int function. Let me try to print the result of this. We're going to see that the result of this is an integer 10. How do we verify it? Let me try to print the type of the converted string value, which is nothing but a data object of class int. Okay, let us now take a look at what is the size that integer data can be of. If you remember our theory lecture, we mentioned that it's theoretically possible to store infinite range of values. Okay, In our coding lecture, let us now try to probably create a bigger or a larger value by using power operator. Let's say I'm going to use 2 power 1024. This will be a huge number which starts from 179763 and so on and so forth. So this entire value is a single value element, and that's an integer value which is created out of some operation that we did. Okay, let's verify whether it's still an integer or not. Again, using the same technique of print type of this long value, and I'm going to close the parenthesis, and it still says that yes, I'm still of integer data type. Okay, before we wind up our coding lecture on numbers, and that too especially integers, let us take a look at the memory management or memory allocation of integer data type. Okay, before which I'll try to introduce you guys to a new term called immutability. Yes, what do we mean by immutable? Immutable just means that something that cannot be changed. So integer falls under the category of immutable data type. So integer is an immutable data type. What do we mean by that? Can we never change the value that's been created? Yes, we cannot change the value that is created in a memory location. Let's now take a detailed look of the same by creating some integers of specific value. Let's say I'm going to create a value called 100, and there is some kind of a memory allocation which is happening for this value. How do we find the memory details or the memory address of this integer is by using a function called id and passing the value 100 to it. Now this 183.066.7824 is the memory address or id of the memory location in which the value 100 is stored. Let's say I'm going to compute 50 into 2. Result of the simple computation is again 100, and we'll be surprised by seeing the result. This 100 is again pointing to the same memory location or id in which the prior 100 is stored. So anytime the value 100 is computed or seen in the course of a program, it points to the same memory location as it was initially defined or created. Okay, we also have another mechanism to verify whether the two objects are pointing to the same memory location or not. Here we go. Let's say I have a value called 100 which is stored in a specific memory location, and I have a computation performed as 50 into 2. If we now want to verify whether the result of 50 into 2 and the value 100 is pointing in the same memory location, we can use the operator called as is. And this returns a Boolean result as either true or false. It returns true if the value 100 and the result out of the computation 50 into 2 points to the same memory location. Okay, before we wind up this lecture, let us have a quick recap of what we discussed in this session. First of all, we got introduced into the major types of Python numbers that are available. Followingly, we went into the details of two major types of Python numbers, which are nothing but integers and floats. And then we jumped into our first coding lectures on integer, wherein we discussed the different operations that are possible on an integer, followingly finding the type of an integer and verifying its memory details. Up next, we are going to understand what are variables, how do we use variables, and then we will get introduced into floating point numbers via our coding lecture. Till then, have a great time, take care of yourself, see you in the next lecture.